All right. Hi, everyone. I'm Chris Unkel. I'm a distinguished engineer here. I've been with DriveScale for 4.5 years now, so I've been here through the entire product development. And since BP just told you about the product, I'm going to complete the second half of Show and Tell's evil twin, Tell and Show. So what I'd like to do for you is to do the things that Brian just described the product as being capable of doing. So I'd like to show you our composer through the GUI and take some pools of resources, put them together in a cluster, shuffle it around, make another cluster, put that back to the free pool, and show you all the options that you can get in that and convince you that this is an easy thing to do by doing it in front of you. So, when we say, the management, this is the GUI, which is of course a web-based GUI, and here's the inventory, which is the first thing that you would probably look at after you've gone into a data center, installed some hardware, installed a management system, installed the composer, and configured everything to talk to each other. So we have a very small development environment here, which consists of 8 servers, 4 of which we've turned off, and 1 of our flash arrays populated with 24 drives. And so we can start to take a look at the thing that the system sees and what it wants to tell you about them. So I can take a look at some of these online servers. There's 4 of them. And I can look at some of the details of them. And these are the things that we know about, or some of the things that we know about it, including the number of cores that it has, which is important because this is something that you might want to know, the amount of memory it has, and the version of our software that's installed. So likewise, we have some drives, a lot more drives, about 24 of them, of a wonderful melange of NVMe SSDs suitable for testing our environment. This is a QA cluster. And we can see where they are, what the model is, and that these are all NVMe drives, which slot they're in, that most of them are available. We can see that there are some network switches. So we've discovered this both from the point of view of the adapter and the servers that are attached to these things. These are listening in LDP. There are 2 10-gig switches, 200 gig switches in this environment, and a management switch, which we also see. So we observe those existence of things, and we know which of the servers and which of the adapters are connected to this. So later, when I go to make a cluster, it will be able to either confirm that things can talk to each other quickly or tell me that I can't have something because 2 things are in different racks in this case. There's 1 JBOD in this case, so enclosure of drives, in this case referring to our flash adapter, which has dual redundant adapter cards, the 2 blades that Brian showed you in the picture of the back. And we're deployed with a triply redundant composer, so a triply redundant management plane of our system. All right, so if I have a bunch of resources, I would probably like to go put some of them to use. And so what we like to do is to go find some suitable servers and drives and put them together into a node that I can use. And as BP told you, the way that we think about that is through templates. And so here are some templates available in the system. And these are testing ones. These aren't anything that it ships with. These are ones that are handy for this particular environment. And what I've done is gone ahead and make us a template for Tech Field Day. And so you can see all of the options that are available to a template. And this describes what I want in the combination of server and storage. And all of the checkboxes in here are things, the way, and everything that the user needs to know in order to get all of the features that we've built over the past 4 years. So, okay, what am I looking for out of the compute when I go to, well, okay, I'm not very picky. I would like something with 16 cores. So, a recent machine. I'm apparently not very fussy about how fast they are or how much memory they have. Probably that's because everything in here has these ones. And there are also ways of adding tags. You're saying, OK, well, there's specific servers that are good for certain things. And this is a way that an administrator can go in and say, OK, well, I want the server that has Ubuntu 18 installed on it. Or please don't use this server because we're going to be decommissioning it next week. So please don't.
They're all just user-defined tags.
Sorry?
They're all just user-defined.
The tags are all just user-defined. Yeah. Exactly. And you can either say, everything I use needs to have this tag, or everything I use can't have any of these tags. Okay? And then I'm going to want some storage. So what I'd like is 5 drives on every one of these things. So I'm going to make a high-performance application. It's going to use 5 SSDs, each at least 500 gigabytes. And this is what I want from every node. OK, well, how would I like my storage configured? Yeah, I would like a file system on it. The application that I have expects me to take these disks, mount them somewhere, have a file system, and stick its data in there. It doesn't want RAID. If I wanted RAID, I would click the button, but I don't. So we'll have the everything but RAID option. I would like the contents of the drive to be encrypted is what this checkbox means. So this doesn't mean the authorization, the cryptographic security for authorization is, of course, always on, but this means that the contents of the drive are encrypted at rest and also in transport over iSCSI. All right, so this enables encryption just under the file system layer, which means that the data is encrypted as it goes to the adapter, as it goes towards the disk. And I'd like them all mounted on data DS 000, 001, 002. And when I'm done, I'll configure my application for those to be the directories. Likewise, I'm not fussy about which drives are used. Anything that's available in the pool will be fine with me. And I'm going to choose only iSCSI. So by default, it would use whichever one of these it was available, as long as both ends could do it, again, as determined by our discovery. So we have a server agent. If you have a compatible network card in there, we know that the server is capable of doing that. Likewise, if you're running on a flash card, we know that's capable of Rocky. And if you've told us that your network is capable of transporting Rocky, we'll do it. All right. So I shouldn't need to save that template since I haven't made any changes to it. And we will go and we will make ourselves a cluster. OK, so here are all the clusters. This is an empty cluster, and I'm going to use the normal create cluster. We're going to make ourselves the tech field day cluster. And there are not a lot of servers there, so we'll make a small cluster. Not 200, but 2. And we will use the tech field day template. And it's thought a little moment. Now, in order to make my cluster, made my cluster. And it looks like the 2 servers are still working on connecting the iSCSI ones. But while we've done that, let's look at what it means that I've made what's in my cluster. OK, yeah, they're still formatting the file system. All right, so as I asked for, I got 2 nodes. It picked me a suitable server. I can go off to it and see which one it picked if I want. So that's one of the 2 servers it picked. Done. Made file systems, and it has picked on each of these nodes 5 SSDs and mounted them on a number of places. So it's picked a drive from a particular JBOD. It's using iSCSI. It's mounted on this particular volume. It has dual redundant paths. So, of course, I have dual redundant storage heads in this case. So it's made both of those paths. It has chosen a load balancing for that. So it went out, it looked at the disks that were there, it looked at the servers, it said, yes, these disks can get these servers, I will use this one. It has instructed the agents on both sides where to connect. The agent on the target made iSCSI portals. The agent on the server used those. It picked which one of these portals will be used first, so it will balance across the portals. It made keys for the drive, and it distributed the authorization keys both to the server and to the adapter. It distributed the cryptographic keys for the contents of the drive to the server to which it is currently attached and nowhere else. And probably any number of other things that I wrote code for and have now forgotten need to be done.
Sorry, Mount point. It's I thought you were providing the device itself, not a mount point.
So for many of these applications, it's a convenience to the user to also format it. So if I had gone in the template and had said, for instance, raw device, then what I would get here was a block device.
Okay, so everything is up to the application or Ansible or whatever they use to configure their cluster.
So in most of these applications, formatting is a convenience to the user because the drive does want to be mounted somewhere. And then since we can react to drives being substituted, added, removed, if I go back and remove a drive from this and replace the drive, I can format this. Our agent can format the replacement for you.
Then I miss another thing. So you do not provide the boot disks. Then you are not able to provide boot disks. So the system, the node has Linux installed plus your software.
Exactly. So the configuration of the node is not a diskless node. It normally is a disk with a boot drive onto which the automation has installed a Linux distribution and then our agent.
Okay, so you have a first installation that you have to do all across your data center, Linux, your software, and then you can start delivering the other resources.
Right, and in many environments, that's the only one that's there. If you know what the application is, you've already positioned the application software at time. There are other environments in which, for instance, we've done Ansible deployments that slave from the management servers, where you would go make a cluster and there would be a set of Ansible resources that follow from this cluster, and you say, oh, the DriveScale Composer decided that these are the servers I should use, and then you can write a set of Ansible rules to install the application software on the two servers that.
Yeah. So if I start all of it using your application, your infrastructure, I can do everything with Ansible taking advantage of the API.
Yeah, Ansible or Puppet and some combination of that and scripting through the API. Okay. And that's, at scale, that's how we see things, frequently happen. And we have a customer who does this with Puppet, right? So they use the GUI, of course, for monitoring, for diagnostics, and for alerting. But when they go to configure a node, their Puppet rules ask us to configure things.
Don't you have any customer asking to remove also the boot disks from the servers? Don't you plan to add also this? Or I want to buy a piece of hardware, which is just a compute device, and find a way to get a dumb compute device. I know that it's dumb to compute device, maybe.
I feel Tom wants to answer this question.
Yeah, so there are people out there who run truly diskless servers today, and there's a few products as well. But where we are now, we're orthogonal to that, so you can still do it that way, and then our stuff to add data disks. So we don't preclude you from doing that, but in the future we may want to integrate that kind of thing.
Okay.
Because it's kind of cool, and statelessness is a good thing.
Yes. Yeah. Right. So you could, see if you had a Pixie booted Linux image that had our agent on it, of course it could get some disks.
Right.
Our existing customers, for them in a lot of the scale-out environments, that means that on a restart, the Pixie boot infrastructure gets pretty heavily loaded, and so their reference configuration. So when AppNext, this is one of the things they're trying to accomplish is to eliminate this outlying Hadoop SKU. So their normal SKU has a boot disk in it, and that's all it needs. And what we've enabled them to do is to remove all the non-boot disks and make the Hadoop servers use the same SKU as everything else.
Oh yeah, so also they have these boot devices that probably are on a small thumb drive or something like
exactly. It's a SATA drive or an M2 drive or whatever it is that fit into the server.
And just a quick question, we talked about they were slicing. I'm seeing the raw disks being presented there, or are these over iSCSI being sliced into the 500 gig volumes? Or was that the minimum requirement?
In this case, what I asked for was an entire, well, I wasn't specific about this one. What I asked for was something that was at least 500 gigabytes.
500. Okay.
And so I got entire drives, and these ones will be at least 500 gigabytes.
Okay, that's fine.
I believe there are not any configured slices in this one. If it was sliced here, what I would see here would be a slice.
That's what I thought.
I would see a slice. Okay, so So great, I have this cluster in here. So let's say that I want to go and use these 2 servers for something else for a little while. So they've got data on them, which I can't throw away. But if I'm not using that data at the moment, what I can do is to remove the servers from this. And so that's a feature we call suspend. Yes, I really would like to suspend the cluster. So I suspend the cluster, and now if I go and look at what's inside it, it's got the same logical nodes, but with no servers. So now these collections of drives, which some applications know about, are preserved. The data is still on them, but they're no longer attached to those servers. And that means that the servers are now available to me. So if I go back to the collection of resources that are available and look at what's there, I'm going to see that I now have those same 4 servers that I had available to me. Some of the drives are still in use. So I can see here that here are some drives that are available, and the drives are still used in the tech field day cluster. And so what I can do with that now is I can use the easiest way of making a cluster, and I can use those resources to make something else. So I can make myself a little scratch cluster. And this time, yeah, still XFS because it formats quickly. No encryption this time. But I will take myself 2 servers with 1 drive, which I don't need to be spinning. And right there, it's telling me that there is no spinning media available to me in this cluster. Okay, it's gone back. It's thought, yes, I can do this for you. And again, now I have a temporary cluster. And if we go and look at this, we've got the same 2 servers now in use with some different drives. And this time it looks like it picked Rocky v2 for me because I didn't ask, and it's available to me.
So it would default to the fastest available?
It defaults to the fastest thing that is available. All right, so another reason we might want to go shuffle drives around is if a drive fails. So I've got this drive that's in use, and if I've noticed that there's something wrong with it, I can assert that it's wrong, in addition to, for instance, the system discovering through smart that the drive says that it's wrong, or it's misbehaving, or going out of inventory. And now that this drive is failed, I can go to the cluster and ask it to replace all the failed drives. And there's 1 failed drive in this cluster, and it's asking me if I would like to replace it. And again, it's done the same sort of templating thing. It looked at that drive, it looked at what it did, it looked at what's available in inventory, it looked for a drive that was as big, that was also an SSD, and it unmounted the drive that was there, detached this other drive, did all of the setup. So I hope that makes sort of concrete what the idea of disaggregating and putting the clusters back together is, right? So I have to start with these pools of resources, and I can combine them so that I have a server and storage deployed in the way that's useful for the application. And at the end of this, I can delete all the clusters, delete the temporary cluster, and go back and see that those resources have been restored to the free pool. So again, just like I did before, I had that temporary cluster, I have those drives that are allocated to the tech field day cluster. But all the 2 drives that I was using for the temp cluster are now back and available again. Okay, and that's the core functionality. So it's a very simple demo of the Composer. And hopefully that sort of makes,
How do you charge for the product? So the licensing model, or?
So it's licensed per server and per drive.
Okay.
So one of the options I didn't see there that I thought I would expect to see is rack availability, or between rack. I mean, I'm assuming you have multiple racks here.
Yes.
So
That rack awareness.
rack awareness. Thank you.
Yeah.
Yeah, so it's hidden behind the scenes. So what actually happened is, this is as BP says, so we show you the racks, and you can see which domains a server and a drive are available in. So if I go to the server, I can see which bandwidth domains here it's available in, and that's telling me which failure domains it's the property of. I don't see that. We don't show that to you in the composer or in the composition thing. What happens is if there isn't the correct combination of those two things, it says, yes, you have some servers and you have some drives, but they're not in the same place, and I can't attach them for you.
You're getting that basically from the LDP information
there
on the
are-
switch going, these guys are all talking to the same top of rack switch.
There are 3 available policies for that. So you can get it from LDP, you can infer it from subnet. So you can infer it from the IP address based on the subnet, and you can also infer it from the IP address and a user-defined mask.
Okay.
And that also makes possible things like I assert that I have lots of uplink, and you should feel free to do whatever you want.
Okay.
Which is
I don't want to sound skeptical here.
But
So if you're planning to deploy a large 1,000 node cluster for the Magic Hadoop or whatever you are planning, so okay, you solved the problem, but all the networking, all the switching, VLANs, stuff, so this is just a little piece of all the cluster. I mean, so that's the TCO of the solution, okay? Okay, you saved me from buying disk inside and some flexibility, but every now and then I have to make changes. I have to change my Ansible script. So there is a lot of work around a cluster. So I thought it was, this is composable storage. It's not composable infrastructure yet. So this is the first step in something maybe bigger. I want to. My wishful thinking is, okay, I have this interface. I want to configure my switches. I want to make all the network working properly, all the IPs and whatever, and like magic, in a couple of hours, I have my 1,000 nodes deployed. In this case, all the rest is still the old-fashioned way.
The switches. Yeah, I mean, in the environments that we've been in, there is established infrastructure for doing that, right? So, what we needed to be in that environment is, we don't configure the switches. What we are is we understand what the switch configuration is and do the right thing.
And you're talking about something that is generally very flat, homogeneous types of environments. You're not talking an environment where VMware where you have like 20 VLANs because you've got different application security zones.
Yeah.
These are big clusters where everybody's in the same network.
Yeah.
Well, actually, the example was the 3. So the example in the slides were at least 3 different applications in the same infrastructure, in the same data center. And I think that we are talking about large-scale data centers, not an enterprise data center. So maybe we have thousands and thousands of nodes. I think that a little bit of configuration of the network exists. Even if this cluster has a single network, there are other clusters you don't want conflicting stuff. You don't want, for security reason. There are, I guess, several reasons.
In at least the first deployment when we did this at scale, there are existing Puppet recipes basically for the direct attached Hadoop cluster.
Yeah, okay, so
So what I need to do for them is to make sure that the Puppet rules can interact with our system.
I don't understand. So you are part of the solution. You are not
we're part. Yeah, the customer, we're part of that.
Okay. Okay.
With networking specifically, there's so many other automation solutions in the space, particularly targeting data center where these guys are going to be. It'd be, why would you enter that market?
Right.
You could partner with someone or integrate with APIs.
No, yes. So, but at the end of the day, this is part of a larger solution. This is made of several components.
Yeah.
You still have to manage.
And the connection to that is supposed to be the API. So we show you the GUI here, and of course the API, and we've started to build things either at specific customer deployments or more generically. Okay, so we're a little bit over time. I can briefly show a Kubernetes demo.
Steve? Kubernetes?
You guys want to see Kubernetes?
Yep, I'm in.
We got time.
I'm into it.
As long
All
as
right.
they're in, we're in.
Yeah, it's a. Okay.
What all the cool kids do.
Right.
That's why it's called Kubernetes.
If I can get to the, if I can get to the desktop.
Isn't it Kate plus 8?
Yeah.
A K8S, yes, is the lazy way of typing it.
I know. I read it as Kate every single time. Kate.
Okay, there we go. All right, so I'll show you first what happens when you deploy Cassandra on Kubernetes. So we have a little setup where basically we've taken, and I've run this as a video so that I don't have to type things in shell windows while I'm trying to describe it to you. But the setup here, and I'll talk while the not DriveScale solution runs, is that we have a very small DriveScale installation and Kubernetes cluster on which there is a Kubernetized version of Cassandra running. And so here we have without DriveScale. So that means you have to use node-attached storage. And so the question is, what happens if a node fails? Okay, well, it's pretty easy to test this out. I can go drain the node, as it's done in this case. So the node is drained. One of the 3 Cassandra instances is stopped. And I think it is currently working on removing the node. And so when we add the node back, of course, Cassandra is going to come back. Cassandra is a scaled application. It knows what to do when one of the nodes has failed. It's going to start re-replicating the data. And here it is. The node is, the replacement is back, I believe. And it is re-replicating the data. But as we see from the graph at the bottom, it's doing this slowly. So I have this third node, but it doesn't have any data on it. It has to spend its time copying the data around. And the result is that the throughput that it's able to give us is in fact quite limited. So that's the end of the first one, I believe. So if we do this with DriveScale, so in the second instance, we've deployed the same configuration, but using in this case, the Flex Volume plugin. And so what the Flex Volume plugin does is allow a persistent storage node to follow pods around. And so if I do the same sequence of events, starts off, drain the node, running, and at the conclusion of this, what it can do is it can take that same storage. So all of the data that was attached to the Cassandra pod in the first storage node, and it can just attach it to the new node. And so at the conclusion of this, in a moment when it's done, what we'll see is that the data there we go. The data per Cassandra instance comes back in basically one monitoring tick. And why is that? Well, that's because all of the data that was available on the node that was drained is now available and has been inventoried. And so we changed something that would be a reconstruction process that if the node was full would take as much time as it takes to write the disk into something that it takes to, in the time that it takes, basically that it time to take to do that demo, right? To detach a drive and attach it somewhere else, which is a few seconds.
So let me talk about what AppNexus plans to do using this technology. So they have about 1,400 nodes running an index of everyone's cookies, and they run it every day. They throw away the 91st day and add last 24 hours. And it takes them about 10 to 12 hours to re-index that data set. They take that index and put it on their Aerospike cluster to do the selling of ads in their customer base. But for 12, 14 hours a day, that Hadoop cluster that does that big index is sitting idle. What they're going to do is they're going to suspend the Hadoop cluster. All the disks suddenly become disconnected from all the servers. They're going to fire up containers on that 1,400 nodes. They're currently containerizing all of their other peripheral applications. They're going to fire up those containers on this available set of servers, and DriveScale will automatically attach the data sets to each of those containers. And they've got 12, 14 hours to run all their other apps. And then at the end, when it's time to redo their index, they'll shut down all the containers, recreate the Hadoop cluster, and then it's off to do the index. So they're going to be able to get rid of all of their peripheral servers and just use their MapReduce platform for all the peripheral applications, and save them. So basically, this makes the compute resource fungible. You can move the compute resource around to different data sets and get your work done.
And you eliminate the data copy problem that's
right.
constant.
That's right. So they're in the middle of implementing this idea. The first step, of course, is to containerize all the other apps. They're not going to bother to containerize the MapReduce cluster. When it's running full blast and takes all the resources. But they'll use our suspend feature to disconnect those drives from the servers when they're done with each day.
And then just keep it around until the next day, and then it reattach.
Then they'll shut down all the containers, and then I don't know what the command, unsuspend. What do we do? Anyway,
it's in fact called reanimate.
Reanimate. They'll reanimate the cluster. All those servers will get attached to that data set, and then off they go.